In this video, I am going to explain acid, bases, and salts. Acids are substances which are sour in taste and turn blue litmus red. Okay, like examples are lemon, oranges, mango, tamarind, etc. So they are acidic in taste. So they contain some kinds of acids. Bases are those substances which are bitter in taste and turn red litmus blue. They turn red litmus blue. Okay, and examples can be the guava. Okay, and also can be one vegetable known as gourd, G-O G-O-U-R-D, gourd. That we call it in Hindi. We call it Kerala. In Hindi, we call it Kerala. Yes, this is so. That contains a kind of base. These litmuses are natural substances, so they are obtained from lichen. Lichen, is a plant belonging to a Thallophyta group, and it is a combination of algae and fungi together. And it is very good examples of symbiotic relation in which both of the individual get benefit from each other, lichen. So algae prepare food for fungi, and the fungi absorbs water and minerals from the soil, and give it to algae. So this is a good combination and a symbiotic combination. Some synthetic indicators are also available. So one is the methyl orange, and other is the phenolphthalein. Methyl orange is it is red in acidic medium and yellow in basic medium. Methyl orange I am talking. It is red in acidic medium and yellow in basic medium. Phenolphthalein, which is just like the color is water. Phenolphthalein is colorless. It is colorless. So it is colorless in acidic medium, but it turns pink in basic medium. Phenolphthalein is colorless in acidic medium, but turns pink in basic medium. It's okay. So how to recognize acid? And salt is neutral. So any litmus, whether it is natural or synthetic, have no effect on salt. And salt is a combination. It is formed by the reaction between acid and bases. Therefore, they are the salts. Some salts may be basic in nature. Some salts may be acidic in nature. So that we will study later on. But in our ordinary cases, salts are neutral, so they don't have any effect on litmus paper. And now, behavior of acids with metals. Behavior. So let me tell something about more natural indicators. So like it is tamarind. In tamarind, you might have seen at home when soaps are rubbed on cloth having yellow. It means having, suppose if vegetables suppose anyhow fall in your cloth, and if you rub soap on that, it turns to be red tissue. Yes, so tamarind is actually it is yellow in color here, but in basis it changes to red in color. And acidic medium has no effect on tamarind. Other is a red cabbage. Okay, there it is some petals of flowers. Okay, hydrangea, petunia, and geranium. So these are the natural indicators. Okay. So these are known as acid basis indicator, or simply we call it indicators. Now the reaction of acids with metals. how do metals react with acids? How do metals react with acid or acid reacts with metal? Okay, most of the metals they react with sulfuric acid and hydrochloric acid to give hydrogen. Most of the metals. Uh, so metals liberate hydrogen from acids. Metals liberate hydrogen from acid. For example, if sodium reacts with hydrochloric acid, okay, it will okay the reactant the product will be sodium chloride and hydrogen gas. So in the same way, okay, if sulfuric acid reacts with potassium, okay, potassium will get potassium sulfate and hydrogen gas. It is so acids okay react with metal to produce salts and hydrogen gas. Now, how can we recognize that it is hydrogen gas? Now, how can we recognize? So, now hydrogen has a has a has a property of itself. Hydrogen burns itself. Hydrogen burns itself. Okay, and with the pop sound. Okay, hydrogen burns itself with pop sound. So if you bring a burning splinter, matchstick, okay, near the hydrogen, the mouth of the test tube containing hydrogen, it will burn immediately, produce pop sound. Is here. So that is hydrogen, taste of hydrogen. So usually acids react with metals to give hydrogen and salt. But the behavior of nitric acid is a bit different here, because nitric acid is a very strong oxidizing agent, so it does not produce hydrogen while reacting with metals. It is here because that immediately converts hydrogen into water. That's here. So the behavior of nitric acid with metals is a bit different. Now the next is that I'm going to tell about the behavior of acids towards carbonates or hydrogen carbonates. Okay, how do acids react with carbonates and hydrogen carbonates? So acids react with carbonates or hydrogen carbonates to produce salt, carbon dioxide, and water. These three things. So there will be one salt, carbon dioxide, and water. This is your whether it is carbonate or hydrogen carbonate. Hydrogen carbonate was also known as is also known as bicarbonate, like HCO3. HCO3. Like suppose if sodium carbonate react with HCl, you will get sodium chloride, carbon dioxide, and water. I'm showing you this reaction by writing on a board. Okay, see now. So it is sodium. I'm just writing it now. Sodium. So sodium when react with sodium when HCl react with sodium carbonate. So you will get sodium chloride, carbon dioxide, and water. It's okay. You'll get like this. This is the reaction. This is salt. NaCl is the salt. Okay, you can just put 2 here, to balance it, and 2 here to balance it. I think it is balanced equation. Just you can see it is here. You can see like this. So sodium carbonate react with acid or acid react with sodium carbonate. The product is sodium chloride, carbon dioxide, and water. This is right. This is balanced equation. So one thing here, whether it is carbonate or hydrogen carbonate, whenever they react with acids, you must get the 2 things. One is the carbon carbon dioxide and other is the water, and salt is to get corresponding salt. Suppose if the same thing, if sodium carbonate react with sulfuric acid, what you will get? Sulfuric acid, it is H2 and just H2SO4, okay, plus sodium carbonate. So you will get the same thing, sodium sulfate you will get, okay, sodium sulfate plus carbon dioxide, and you will get water, okay, you will get these things. Okay, you are getting sodium sulfate, carbon dioxide and water. Okay, I'm just saying that you will get carbon dioxide and water, sure it is here, sure, and one salt you will get, corresponding salt, this salt, this salt you will get sodium sulfate, you will get this one. Okay, when the acid is sulfuric acid, you will get sulfate salt. When the acid is hydrochloric, you will get this chloride salt. It's okay, this like this. And in the same way, hydrogen carbonate also react with acids to give these things. Okay, I'm showing you all. Okay, this is hydrogen carbonate. It is. I'm showing you, like sodium hydrogen carbonates, or so we can say sodium hydrogen carbonate plus it is HCl plus HCl. Okay, so we'll get sodium chloride. Sodium chloride you will get, water you will get, and carbon dioxide you will get. This is, you'll have to balance the reaction always. Balancing of reaction is always required. Now this is the reaction. This is C. This is sodium hydrogen carbonate, and what you get is that this is the acid here, sodium chloride you are getting. Sodium chloride you are getting here now, and water and this carbon dioxide you are getting. It's okay. This is a gas. Carbon dioxide is a gas. This is. So once again I am repeating here now. So carbonates or hydrogen carbonates, they react with acids to give salt, corresponding salt. Corresponding salt means if the acid is HCl, then you will get chloride salt, and if it is sulfuric acid, then you will get sulfate salt, and one carbon dioxide you will get, and this water you will get. It is sure to get, yes. So this, in this way they react, the acids react with acids, this carbonates and hydrogen carbonates. This is. Now the question is that how, the important question is here, that how can you recognize carbon dioxide? Okay, how can you recognize carbon dioxide, that it is a carbon dioxide gas? Okay, carbon dioxide gas be recognized by passing into a lime water. You know what is lime water? This is calcium hydroxide, is a lime water, is known as lime water. Calcium hydroxide. So what is the color of calcium hydroxide? Calcium hydroxide color is watery. It has no color. It is just like water. So calcium hydroxide. So calcium hydroxide plus carbon dioxide. So you will get calcium carbonate plus you will get water. Okay, calcium carbonate plus water you will get. This is a calcium hydroxide is in aqueous solution, and this is you will get PPT of what is white in color. This is calcium carbonate. Okay, see here. This is lime water. This is lime water, This is lime water and this is carbon dioxide. So when carbon dioxide, okay, is passed in lime water, okay, the product is calcium carbonate, which is insoluble in water, and they come up as a solid, small, very tiny solid particles, which appear as precipitate, white precipitate, and this is water. You get water, okay, water you get. So this is uh, so this is the only one gas, carbon dioxide, which turns lime water milky. This is milky. White means it is milky. This you know. Now, if we go on passing carbon dioxide, okay, more and more, now the milky color will disappear. The milky color will disappear. Okay, why it is disappear? It is because of the formation of calcium hydrogen carbonate, and which is soluble in water. Just I am showing you. Okay, this is calcium carbonate plus water plus carbon dioxide. So you will get calcium hydrogen carbonate. You will get. It is like this. See, this is soluble here now. So this is soluble. This is soluble. It is colorless. It is colorless. It is calcium hydrogen carbonate is colorless. Okay. So this you will get. Okay. If you go on passing carbon dioxide, this one in this in the solution calcium carbonate water, you will get this is calcium hydrogen carbonate. This is soluble. Okay. So it becomes colorless. So this is the in this way we can recognize carbon dioxide. Once I am again repeating it, okay, how can you find out that it is a carbon dioxide? Is that if you pass carbon dioxide in lime water, the lime water changes into milky color because of the formation of calcium carbonate, which is insoluble. So that appears as very tiny particles, okay, white tiny particles, and that is called precipitate. But when you go on passing more and more carbon dioxide, okay, the milky color will disappear and it will become colorless, just like water it is here, because the formation of calcium hydrogen carbonate. Calcium hydrogen carbonate is it is colorless. It's okay. That is why it appears as a watery color. It's okay. So now in next video I will talk about some other reactions. Okay. So let me tell you one more thing about the bases. The reaction of bases with metal. Reactions of metals. Reaction of bases with metals. You know, metals react with not many metals, but zinc and aluminum, they react with this bases to form sodium zincate and aluminum zincate. It is. I'm just showing you now. You know, this is sodium hydroxide plus zinc metal, zinc. So zinc, like just like it looks like aluminum. So you'll get sodium zincate. You will get sodium zincate. You will get, and you will get an hydrogen gas. Sodium zincate and hydrogen gas you will get. This is sodium zincate. Sodium zincate. This is a salt. This is a salt. This is a salt. This is a salt. So this is salt. So in the same way, aluminum reacts with sodium hydroxide to give aluminum. This sodium aluminate. This is sodium zinc. This is sodium zinc, and with aluminum you will get aluminum zinc. Okay. You will get sodium aluminate. You will get with aluminum. You will get sodium aluminate. Right. This is so. Not many metals they react with hydroxide. We have to study only two metals, the reaction of two metals with zinc and this aluminum with this basis. Sodium hydroxide and calcium hydroxide, potassium hydroxide. So they are the strong bases. They are the strong bases, very strong bases they are. Yes. So now that's all today, and we'll do some more work on acid and bases in the next video. It's okay now? So be happy and watch it and tell me your reactions. Thank you.